Hi class, my name is Felix Rivera and the topic of my presentation will be the Halo network. Today's global communications infrastructure needs to be built with the right components to support the increasing demand for faster, better, and less expensive services. At times when conventional ground and satellite systems are facing higher costs, a low-cost solution is being advocated and welcomed by many. One of these solutions is known as HAPS. HAPS, which stands for High Altitude Aeronautical Platform Stations, is a technology that provides wireless narrowband and broadband telecommunications services as well as broadcasting services with the use of airships or aircrafts. They operate at altitudes between 3 to 22 kilometers, covering areas up to 1,000 kilometers in diameter. The platforms could be airplanes or airships, and may be manned or unmanned with autonomous operation coupled with remote control from the ground. The combination of altitude, payload capability, and power supply capability makes it ideal to serve metropolitan areas with advanced telecommunication services. They are mostly powered by solar energy. There are two types of HAPs, stationary and airplane-based. HAP platforms are positioned above coverage area. For broadcast applications, a simple antenna beams signals to terminals on the ground. For individualized communication, such as telephony, cells are created on the ground by some beam forming technique in order to reuse channels for spatially separated users, as it is done in cellular service. The Halo network is an airplane-based type of HAP. Halo stands for High Altitude Long Operation. The aircraft is located in the atmosphere, miles above terrestrial wireless, but thousands of miles below satellite networks. The packet switch network will offer bit rates to each subscriber in the multi-megabit per second range. The Halo airplane is the central node of the wireless communication network. It has an initial capacity of 10 gigabits per second, with a potential growth for up to 100 gigabits per second. The hub is located in an aircraft known as the Proteus. It is carried in a large pod suspended from the underbelly of the aircraft. It houses the antenna array that creates from 100 to more than 1,000 of virtual cells on the ground. Each of these cells covers an area of a few to several tens of square miles. The cells created by the antenna array will be fixed on the ground, and there will be no overlapping area between adjacent cells. The cellular pattern will cover a metropolitan scale area. Each cell on the ground is covered by one spot beam. The spot beam that covers the cell changes due to the motion of the aircraft. A given beam covers a given cell on the ground for a duration of time called dwell time. Once the duration is exceeded, the beam must ratchet over by one or more beams to cover a new cell on the ground. The antenna array will produce beams of two types: a shared beam, which provides services to 100 to 1,000 subscribers, and a dedicated beam, providing connection to a gateway serving high bandwidth users or to a gateway servicing users from non-Halo networks. Halo Networks combines the advantages of satellite and terrestrial wireless network. Broadband facilities are provided through customer premise equipment or CPE for home and small offices, and business premise equipment BPE for business purposes. It can also be connected with non-Halo networks like ATM networks and internet service providers. 1 to 10 megabits per second will be offered to individuals and small businesses, 10 to 25 megabits per second to businesses with larger bandwidth needs. The Halo network has been already tested in certain parts of the country, especially on the West Coast from California to Seattle. It is currently waiting for FAA approval for the use of the aircrafts. Other hub projects currently are the Sky Station, the StratSat in the UK, the Sky Tower, which has been supported by NASA, Google Internet, and Project Loon, which is currently being tested in Africa, Asia, and New Zealand. The advantages of Halo over terrestrial networks are: Halo does not require many base stations interlinked by cabling. Re-engineering of the entire network may not be required. High look angle prevents signal fading. The advantages of Halo over satellite networks are: satellite networks require more expensive terminals. The capacity of satellite networks can only be increased by adding more expensive satellites. Halo networks can be financed one market at a time. It is more suitable for developing countries. Halo aircrafts are 10 to 1,000 times closer to the user, allocating significant capacity to densely populated areas. The aircraft central hub can be routinely serviced for optimal performance. I see more and more of this technology being used in the future. Not only it will help everybody economically, but it will provide the opportunity for developing countries to enjoy satellite-like infrastructure. Thank you so much for your time. Have a great day.